Graph the function shown. Identify the period, domain, and range. So we have f of x equals secant of pi x minus 1. And when you first look at this, it doesn't look that complicated. Here you have a horizontal shrink by 1 over pi, and then you're going to have a translation of 1 right, and that's it. But the problem is, this gets kind of complicated, and you'll see that as we go through the process here. We'll just take it one step at a time. First step, as always, is to find the period of the function. 2 pi over b equals 2 pi over pi equals 2. Okay, so the period is 2. All right, what I'm going to do is I'm going to graph g of x equals cosine of pi x minus 1, and then convert it to a secant graph afterwards. So each of these tick marks based on the period is going to be 1. So 1, 2, 3, 4, 5, 6, 7, 8, negative 1, negative 2, negative 3, negative 4, negative 5, and so on and so forth. Okay, so instead of being in terms of pi, the grid lines are going to be in terms of 1. Okay, so the period of the function is 2. Start here for the cosine function at 0, 1, and then the period repeats every 2. That means you're going to have a minimum halfway in between the two maximums. Okay. But then, each one of these is going to be translated one to the right. So what I'm going to do is I'm just going to translate. This actually looks like kind of a cool pattern. This has the same look as a vertical reflection. So the zeros are going to be halfway in between each one of these guys. All right, now I'm going to sketch out the graph of g of x equals cosine pi times x. So I'm going to sketch out the graph of g of x equals cosine of pi of x minus 1. Okay, so that's a graph of g of x. Now we need to convert it to the secant function. So all the zeros become asymptotes, first of all. This is going to be a pretty compact graph here. Okay, well, that's enough to give you the right idea. And then each local max or min becomes a turning point for the branches of the graph. So essentially that's the graph of f of x equals secant pi x minus 1. So how do you do the period, domain, and range? Well, the period we said is 2. And the domain, x is an element of the set of real numbers such that x cannot equal. Now we need to find a pattern with the asymptotes. Now there's an asymptote at 1/2, 3/2, 5/2, 7/2, and it continues the other way, -1/2, and so on and so forth. So what we're going to say is x can't equal 1/2 plus n, because we're going by integers of 1. So every time you add 1 or subtract 1, that'll give you another asymptote. And the range, we're going to go with interval notation. So -infinity, comma, up to -1, and including -1. It's a closed interval on that side, but open on the other. Union with +1, comma, infinity. So this means there's a gap in the outputs between -1 and 1. So there's the domain and range, there's a period of the function, and here's the graph right here. So the main point when graphing here is you want to make sure that when you're graphing a reciprocal function, especially secant or cosecant, that you graph its related reciprocal function first. Like in this case, I graphed cosine of pi x minus 1 and then transformed it. And that's really what you want to do when graphing these.